Hi class. Our next example will be using the method of undetermined coefficients to find the solution of a non-homogeneous ordinary differential equation, which is linear and has constant coefficients. So what I've chosen to try is just number 1 in your homework. Y double prime plus 2y prime plus 2y equals 2x squared plus 8x plus 4. And to start out, we do exactly the same thing that we would do for variation of parameters. We find the homogeneous solution by using an auxiliary equation. In this case, we get m squared plus 2m plus 2 equals 0. And we could use the quadratic formula, or we could complete the square. In this case, we get m plus 1 squared plus 1 equals 0. So m plus 1 equals plus or minus I, which tells us that m equals negative 1 plus or minus I. From this, we can just write down our homogeneous solution. We have complex roots, so we use Euler's formula, and we would get e to the negative x cosine x, because beta is 1. C2 e to the negative x, because alpha is negative 1. And beta was already 1, so we just get sine of x. That's our homogeneous solution. Now, what changes is what happens with the particular solution. In this case, we're going to guess our solution to be something which looks very much like the g of x term here. In this case, this is a polynomial of degree 2, so we guess that yp is a generic polynomial of degree 2. Okay, so we'll give it coefficients a, b, and c. These are undetermined, and our job is to determine them. Well, what I'm going to do is I'm going to plug this back into our differential equation. So I need to take some derivatives and then just ultimately plug it back in. Okay, so now I have my derivatives for y sub p. I'm going to plug them into the differential equation and set it equal to what I'm supposed to get, so that I can get a system of equations for a, b, and c. So yp double prime is 2a. 2yp prime is 4ax plus 2b, and 2yp is 2ax squared plus 2bx plus 2c. If I add up the particular solution that's plugged into my differential equation, I'm supposed to get 2x squared plus 8x plus 4. What I actually get is 2a x squared plus 4a plus 2b x plus 2a plus 2b plus 2c. Now, by equating the coefficient of x squared, x, and the constant on the left and the right, I get a system of equations. On the left, the coefficients are 2, 8, and then 4. On the right, they are 2a, 4a plus 2b, and then 2a plus 2b plus 2c. Once again, this system isn't terrible to solve because one of them is one equation with one unknown. In this case, I should get a equals 1. Now, plugging in a equals 1 here, I get 8 equals 4 plus 2b. So b equals 2. Finally, plugging in a and b into the third equation, let's see, I'm going to get a 2 here, and then a 4 here. So that's 6. 4 minus 6 is negative 2, divided by 2 is negative 1, so c should be negative 1. Alright, well, what do I do with this information? This is my answer. I just plug that in to y sub p. So y sub p should be ax squared, so 1x squared, plus bx, so plus 2x, plus c, so minus 1. That's my particular solution. And ultimately, the general solution is just the particular solution plus the homogeneous solution, just like before. And that's really all there is to it.